All right, the scale is June 12th. All right, we're gonna do a review of the work that we both did. So I think we're kind of starting to narrow in on the problem. So just to set a context here, we had last time we said we would do these. Looks like Lubo went ahead and was able to work out option two, and option two is already showing us something. So I'm kind of inclined to more talk about option two since that seems to be already yielding results, and um, I'm a little bit less sure now about option one. Does that work? I don't know, Leigh, did you get a chance to, is that match your opinion? Did you get a chance to do your revert and were you able to see any results there or
Yeah,
do you think
my
option
revert did
two?
not my revert did not produce results that are below the current trend line. The revert I have open one four. I mean, Jed has opened it 14876. The results
Mhm.
are uh, bad.
Okay. All right. I think I'm more interested in this because I think this is already showing us some information and we had already some idea that what was going on was along the direction of what these results are telling us. So so let me set context. So we had these two changes, a 1.4 release and a 1.5 release. These two are changes using the new infrastructure. Actually, let me back up. So around the time, let me see if I can get it. Where's there it is. Okay. Around this date, Lugo was able to uncover that there was an infrastructure change. And I'm not entirely sure about all of the things that went into this infrastructure change. Um, but that's an important variable because this is what can also affect our numbers. And I think what the most interesting number was when you look down here is this one. This one's a little bit strange, right? It's how is it that some jobs have 76 create pod counts when they should be up here in the hundreds, right? Because we're launching 100 BMIs. This should be more. Um, so when you kind of look at this, what would explain this is that there was not enough resources. So the architecture change did increase memory, and that could explain why now the results are actually more consistent, and actually more accurate than what they were before. So that is a possibility here, and I think that's the case that seems to make sense in my mind that a lot of these data points are actually the same ones we're seeing over here. Like they're seeing some 15s over here, right? But what we're not seeing are the ones up here, 22, 2017, and whatnot, the ones that are pulling up the trend line. And when we increase the memory, we can see that the trend line is being pulled up so that the trend line over here is not it's not fully accurate. That's sort of the case that I want to make is that it seems like that is what's happening. And so we're going to look at these two PRs. So these two PRs from Lubo, these are reverts, or not reverts, they are running with the new infrastructure against the 1.4 and the 1.5 release. So what we'd expect to see here when running these performance jobs is that if it was not the infrastructure, we should see that the numbers are about 15. All right, so there should be if the infrastructure if the what is affecting these numbers is not the infrastructure, it should be 15, right? It should not look like these over here because these releases don't have the changes when that went in around this time, right? And the code changes around November 17th. So we'll go to these. Let me open these up. I had already looked at these, but I will just go over them again. Okay, so the things we're going to look at here is one is the create pod counts, right? First one right here, 111. So this is in line with, that's the number to keep in mind. 111 is this number, right? That's what we should expect. And the trend line should be somewhere between 15 and 20. So if we go down, to the P50, 15 and 20. So we're at 16 and then 28 up here. So this one will be between 19 and 28. And it's 28. Okay, so I pulled, that was the 1.4 job. So this 1.4 release, I get the date of it. The 1.4 was GA'd last year. So long before we saw any changes, right? So this number should be 15. Or this one should be 15. It's not. It's actually showing this data. So this means that to me, this is a really strong case that this is the infrastructure. Something with the memory increase, to my mind, points to the fact that we were not getting enough VMs created here to actually accurately reflect the trend line. That does mean something else is happening, though. I mean, something has changed, and what that is still not clear because um, we in these cases we're consistently getting a certain amount of memory and CPU for these jobs. So, um, what should it be so that it is consistent, right? Why was it that we were seeing, good numbers, I think, for a period of time, and then all of a sudden, we were possibly starved for resources. So I don't know the answer to that question. But it seems to me that this trend line is now back to where it should be. This looks like accurate data to me. And I'll do one more. Let me go to 1.5 here just for the full picture. Okay, so create pod counts 111. That's what we want to see, 111. Performance 16, so between 15 and 22. And this one was between 21 and 28. So this is showing that this version of the trend line, right? So both of those releases are consistent. So it shows that this date, right, is not being affected by code changes. It's by an outside force. So I mean, to me, in my mind, that's what seems to point to it. It's the infra side. So, hey, does that make sense, guys? Like, is that do you guys subscribe to that theory? It seems that's what seems most accurate to me right now.
Yeah, this theory makes sense, although um, we should have dashboards that reflect VMI phase count. If we had dashboard that reflect phase count, we would be able to do this much easier if this theory was correct.
What do you mean a dashboard for phase count?
I mean, a graph along with the P50 and P95 that shows how many VMIs were in running state completed, how many stayed stuck um, before running state, things like that, right? The phase count panel
Hmm.
that can be generated from the phase count metric. We should find a way to add that here.
So
I'm
this one, I mean, you can see it here. Sorry, like I would say, you can see it here. I mean, this isn't even complete. Um, this
yeah.
this one's hard. This one's hard because this one is hard because it's point in time. It's an estimate. These might go to completion, but we're scraping the metric, and this is what we're seeing. Let
So
me
when
see if this
that's
one's any
perfect,
different.
right? So what was the
Yeah, so here's 100.
yeah, okay, this makes sense. So when you're looking at the previous where it was not 100, um, yeah, what is the job here? Are the numbers here 15 and 20, 90?
Now, so you see these are their numbers on, we'll call them the new trend line. We'll call this the old trend line. They're
Okay,
on the new trend line. The numbers are on the new trend line. So 16, it should be 15. It's higher than the old trend line, so it's on the new one.
I see.
Yeah,
Yeah,
so what I'm saying is don't trust these. This is point in time, and I sometimes we don't even get this. So this one can't be trustworthy. The most trustworthy one is this one. Um, because this is I think this is what we use to calculate like some of the I think it's what we use to like base some of the other metrics off of.
so that's what I don't understand. Why so when you say the running count and the schedule count is point in time, is that the same point in time when other metrics are collected?
So I think this one is so I'm trying to remember. This one is like um it does a tally. That's what I remember. It like tallies them up at some point near the end. Um so it might be towards when the job finishes. I can't remember. But the problem is that if you look at these
Hmm.
ones, we're going to get so that's what it is. So this time we don't always get these. That's I think what the problem is. So this is run I think towards the end of the job, and it just checks. I think it does this one time, and it checks what it looks, it grabs what it sees, and whatever it sees, it passes on. Sometimes it's wrong. Sometimes it gets nothing. Um, this is extrapolation, so it's an estimate over a span of time. So it's at least going to be more accurate. You're going to get something here. Like this one you'll always get something. You'll never end up with nothing. That's why I'm saying don't I wouldn't trust these. They're very dependent on when the metric is pulled. Like if it's pulled too late, we could have deleted them all, for example. And that's sometimes it doesn't even get any because of that reason.
Right. I mean, yeah, that's hard. So what I'm thinking is if the data is present, it's more reflective of the situation, right? If the data is not present, then we couldn't do anything. But if it is present, then we should look at it. And the fact that 14 got stuck in schedule phase means that we are going to suffer really badly on creation to running, because that 14 is going to drag that uh, P95 to infinity, right? I mean, not infinity, but much longer.
Yeah, I know it's true. The problem we can't use this number is because I found it to be so inaccurate. Yeah, I mean I think what I'm trying to say is like we know there's a lot of estimates that are being done here. This one makes the estimates I think worse. This one, I don't know. It's because of the number of times you can get nothing here, and or even just like I believe this job will go to 100, and it even might be reflected here. The values might be correct, but whenever this is pulled, um, yeah, what I'm trying to say is that it may seem like this can go to infinity. I don't think so. I don't think this is going to go to infinity. I think these will work. It's just has to do whenever we grabbed these.
Oh, I see. So you're saying that when we grabbed this, the 14 were in schedule phase, but eventually those 14 went to running state, and our tests reflect that because we wait for the VMIs to go to running state, but these metrics don't. Uh,
Yeah, we wait till VMI goes, we wait till they go to running. Yeah, wait till they go to running state, or I think we fail. Um, the only thing is with, yeah, with these ones is that I can't remember when we get these, but we don't, so I forget what it was, but we don't base the P50 off of these numbers because they're so unreliable. The most reliable ones, the most reliable one is this one. Like we're obviously not creating 111 pods because it's estimating, but we can use this number to estimate everything else, right? That's what I'm saying. It's like it's not, this one is not extrapolation. This is point in time. The rest of these are estimates, and so it's the wrong value to use to try and understand these ones, which are estimates.
yeah, I see. I think, yeah, we should move. So I have an idea how we can take running phase count and collect it after the test is run and make sure that it reflects a non-zero number. I I should file a ticket for this. We don't have to discuss all of that here, but as a corrective action, I think it will be great to have a metric that we can trust here that shows at the end of the test how many of them were running and how many of them were scheduled in schedule if they ever got stuck.
So what I remember about the code is that we will we will fail if we don't go to running. That's the thing that I remember. That I think that's what it was, because and we don't fail here. Like I could look and check the job, and it should see like there's 100 of them that went to running. That's why that's what I mean. It's like it's so I wasn't able to find a way to make this reliable. I don't know. We can look into doing it. That's fine, but um it was just not able to find a reliable way to do it. So I think though, like the point
Yeah, yeah.
is we had this metric, and I think this metric was wrong, but this metric, um, so the create to running time, I believe is based off of this. Is based off of this. I think that's or at least the threshold. I think we have a threshold, yeah. So there are so we are, I think what we need to do is we need to use this value. This value is fine. It should be near 100. The problem was this. I mean, these values were below 100. These tests right here are not good. 75. Like that tells me that, I mean, we didn't, or we're pulling data from the wrong place, or something is not right. This should consistently stay at around 100 for it to be accurate. I bet if
Yeah,
we looked at like the longer term data, we would see this, but I don't know when this changed.
I think this is the reason why I have little doubts on trusting this metric. So, if this metric was actually accurate and we were creating 74 pods, then we would be failing the job, right? Because the remaining of the word VMIs did not go into running state. If the word launcher pod actually doesn't exist, then there is no way VMIs are going to go into running state,
Right.
and we would be
But
failing.
but the but you could but the point is the when we're scraping this metric, we're seeing 75, and that metric happens to scrape at the exact same time that we're doing it here, and the value is 15. So that it's something to do with timing here. So the something about the timing. So it could be that maybe the way to put it is that the memory that we had allocated for the job wasn't quite enough and was kind of starving the test, and it was the window we were gathering metrics. It made the window wrong from when we were gathering metrics, made it inaccurate. So adding memory made it so that we had enough resources so that we can get the extrapolation correct at the pulled it at the right time. And that's the way I'm thinking about it. It's sort of because it's not that we weren't getting it's something we weren't getting to 100. It's that it's when we're extrapolating at the wrong time.
Yeah, makes sense. I mean, so with the Kubernetes perf and scale stack, I see that they have a way after the test to export all the Prometheus metrics that the test had gathered. I mean, actual dump of the Prometheus time series data. And what that would allow us to do is take that Prometheus metric and put it into local Grafana and analyze all of this data after the fact. Um, if we had that kind of functionality, I would assume all of this discussion would have been much easier. So I think we should explore that path. Does that make sense? I think we are kind of in the dark trying to understand what went wrong here.
Yeah,
Um,
we are. I agree. That's I think why it's been it's a little bit of a scramble is because it's been hard to identify pinpoint exactly what the problem is. Yeah.
yeah, this will make the storage cost a little bit more, but I think it's gonna be worth it.
Yeah. I think so too. I mean, I think that would be good. That would definitely be good. Okay. Yeah, I mean, to me, I think this is what we should go with. I think like the we'll just need an explanation though. Actually, let me go to Hubert because I do want to see the comparison here to see what's changing because we do publish this. Yeah, okay, so our trend line is between 15 and 20 for the P50. What's it been at? It's been at 15. This is actually let's see, this seems like more accurate trend line. 15 and 20. So this look like 17. Where is it here? It's about 17. It does go up to 20 times, but 18.
Can you look at a more recent release like 1.3 or something? So if you look at the end of this graph, it's June 2023. That's a long
Yeah.
way.
Yeah, you're right. Where's the that was on master or on main here. Where's the is there a
Uh,
new one in
yeah, if you go to 1.3 release,
okay. Oh, that's right. We backward them. Okay. That makes sense. All right, so we go to P50.
oh,
Uh wait.
you might be looking at the wrong place. Not sure. Let me check. Oh,
Here you
that's
go.
right.
So here it is. Here's the 23, 24. So you can see the number right at 15. So wait, November 2023? So wait, go back here to release 1.3.
Yeah, September
Oh, here
20
we go. Okay.
is where we got
Ah,
started.
so here's our trend line right here. So here, oh, Olay, remember we talked about this with so
Yeah,
here's this blue line. Yeah,
that's
so here's our trend line. Here's our old trend line. This it looks exactly like this.
yes. Yeah,
It
that
looks
blue
exactly
line.
like that, and then this is new.
I think the blue line is
It's a Kubernetes release,
1.9.
right?
If you go out of this directory, there will be a doc explaining that.
Yeah, let me go.
Perf scale benchmarks, there it is.
Okay, blue line is wait, it's up here, isn't it? Or where's the key? Is it at the bottom?
No, it's at the top. Yep, sixth bullet point.
Thanks. Here we go. Blue lines in the graph for individual measurements. Orange line is the weekly average. And then blue dotted line was the 127 provider. This change. Yeah, this is what I thought. Okay, is that when this was when we changed Kubernetes releases, and we weren't able to explain what changed.
Yeah, maybe as part of this release is when the memory pressure started kicking in.
So we weren't able to explain it, but maybe that's what the explanation is that memory pressure from Kubernetes started here when we went to 127. And then we relieved the memory pressure with interesting. We weren't able to ever explain that, but that might be what the explanation is.
Yeah. Do you have pod
Interesting.
create count here?
Don't think so.
No, I think there was.
Do we have
Can
it?
you check
Get,
the very
get,
first one?
patch, patch, update, patch, patch.
Ah, yes.
Great to running, great to running, great to running, great to running. No, I don't see it. Yeah, we don't have it. Interesting. I wish we did. I don't know.
We would
I
have
don't know how we get it.
we would have it in the benchmarks directory.
Oh,
Uh,
okay, we have it in the benchmark directory. Okay. Wait,
yeah.
where's not here, right?
No, it's not here. I'm going to share the link.
Okay.
It's in the chat.
Okay, so this would be wait, we need to go am I in 1.4 or hold on. No, I need 1.3.
Oh, yeah. If you
Here.
just change,
Oops, no, 1.3. All right, how do I can I view this as a web page? Oh,
yeah,
actually, I'll just take the wait, how do I
yeah,
get this to a web page? What would I
yeah,
do?
I'm getting there. Uh, okay, this link.
Perfect. There it is. Okay. Right. So if we look at
Oh, that's the create count correlates.
it does, where's
There it is.
oh right there. It does. Look at that. So I think that's what it is. Interesting. But this makes some sense. So Kubernetes 127 had a or 126, one of the two, had more memory, required more memory, and that's what affected us.
Yeah, I'm not sure. Are you sure it's memory?
I don't know, actually. I'm not sure. It's resources, I think. Something resource wise. Whatever this new architecture change, what my understanding is it changed the CI, the amount of memory and perhaps CPU, and that is what brought us back. So that's why I'm saying memory. I'm not sure exactly though, but that seems to fit. Well, I'm not positive though. That's interesting. Um, I'm gonna put this as a note. Great. Yeah. Um, yeah, that's interesting. This seems to explain a lot. Okay. All right, well, we're 4 minutes over. I think this is where we can leave it. This doesn't sound like, I think, this does not sound like a regression convert. This sounds like something else.
Yeah,
This continues to increase my confidence here.
yeah, I agree.
Okay. I think we can, so I think we'll have one more meeting on this on next Thursday. Um, or maybe we can sync with Wibo offline about this, I think. And then, we can take it to the mailing list. Or we'll talk about it next Thursday. We'll see what we get to first.
Yeah, it would be good to get an idea of what changed in the infra. I think it will help understand this better.
Yeah. Okay. Sounds good. All right, we'll end it on that. Thanks, Elaine.